Hey there. So this is the video recording for lesson 614, and you can see the target there is to find out what we mean by least squares regression lines. And using Desmos graphing calculator is largely how we're going to do this, and why it's important. All right. And you can see the assignment there is basically the same as it often is, to answer a few questions about the video as it's playing. All right, so here is the question. Whoops, let me go back one. There we go. All right, here's the question that we're going to be focused on, and it's question 630. You can see by reading it that it's about a professional basketball team. Specifically, it's a record of the number of minutes that a basketball player played and then how many points he scored in the entire season. And you can see that a player by the name of Antonio was left off the list. So what we need to do is predict how many points Antonio scored in the season based on the fact that he played 2,103 minutes. All right, so there's the problem. All right, so I just wanted to share this with you real quick, and you'll see more on this tomorrow. But one kind of cool thing is if you have a spreadsheet with data in it, and in my case I used Google Sheets, you can just copy and paste that data into Desmos graphing calculator. You don't have to retype it. Like I said, you'll see this more on a video tomorrow, but it's really cool. It saves you quite a bit of time. All right, so we're going to start this the same that we did before the vacation. And I think some of you maybe have missed some assignments, and some of you may have forgotten, but that's fine. I'm going to review it real quick here. So the first method that we used, I call the eyeballing method. It's like you try to figure out, all right, where would be the line of best fit? So I actually chose 2 points, 1,919, 688, and 685, 216 as my key points. All right, you can see here, I then use that to get the equation of a line. I'll talk about that in a minute, but I do want to say that puts this line like right about here. Here's 1 point, this 1,119, 688, and the 685, 216. It's going to put the line pretty low. I had to make a judgment here about this, and I thought these two were kind of outliers, so I just left them out. This looked more like a straight line to me. So thing is, I don't know if that's the right judgment to make or not. All right, I'll give you another guess that another thing that I'm thinking about with this at the end of the video. All right, anyway, you can see here's the process. To find the equation of a line from 2 points, you start by finding the slope. So I did the change in y's divided by the change in x's, or delta y over delta x. Right, and then after that, I found, since I have the slope, I can now find the y-intercept. I used the point 685, 216 to figure this out. So here's my y, here's my slope, here's my x, and then I can use that to solve for b. I left some of the math off, but I did end up with b equaling negative 46. I did have to round that to the nearest whole number. All right, so here's my equation, right? Y equals 0.3825x minus 46. And I wrote it the other way around with the y-intercept first, just because in statistics, sometimes it's written that way. Again, I don't know why, but on occasion, that's how they write it. All right, next slide. I think this is better to do just this. There we go. All right, so here is my line, and you can see real clearly that I definitely looked at a couple of points as outliers. But the fact that I made that judgment really does beg the question then, is this truly the best line of fit? And is there such a thing? Or is it all just like people's judgments and different people have different lines? All right, so that's where the least squares regression line comes in, because yes, there is a line of best fit, and statisticians call it the least squares regression line because they actually use what's called the squares of the residuals to figure it out. Right now, it's been a while since we did this, but remember, residuals are the difference between the actual value of data and the predicted value. Right? Well, by squaring that, we make them all positive. Remember, some of them were negative and some of them were positive. So statisticians use those squares to figure it out. You might wonder why they don't use absolute value. And the reason they don't use absolute value of the basically of the residuals is that can actually sometimes create a variety of lines. Again, I'm not going to get into that too much, but you will later when you eventually take some statistics classes, but just take my word for it for now. Using the squares of the residuals is more accurate than using the absolute value of the residuals. I actually took this from a website called MathWords. This is the formula that's used for finding least squares regression lines, and just know you're not going to be expected to use this formula. You're not going to be responsible for it. Eventually, you'll get into it in statistics courses. I do want to show this symbol, though. You see this symbol that looks like a fancy E? That is a Greek letter, and you know what? I don't know what letter that is in Greek right now. I'll have to look that up and give that to you in a later video. But in mathematics, when you see that, that just means the sum of all of these numbers. So in this equation, in order to find the slope, you're going to take the number of points total and you multiply it by the sum of all of the values for the points when you find the product of x and y. All right. Again, I'm not going to get into that too much, but just wanted you to kind of know what that symbol means. If you're really into this, though, this is the formula that's used to figure out the least squares regression line. The nice thing for us is, though, we're going to have Desmos just do it for us. All right, so here's what you do if you're looking for this in Desmos. All right, so right here I've got the directions. You just type your data, and then you type this formula in. Now, the reason you have to use X1 and Y1 is because basically we have this just one table here, and since we're using these values, this is what we put in. If we were to put in a different table, it would be labeled X2, Y2, so then we would change that in our formula. All right, so basically it's just the formula for the equation of a line, except with these subscripts. And then this right here, this symbol is referred to as, I think it's called tilde, and that's a Spanish word. You'll find this on your keyboard, or in Desmos calculator, you can find it on their keyboard. In this case, it's going to mean approximate. And this tells you that this is actually just an approximate line. Not all of the points will be on the line. Right, but this is the formula you type in order to get Desmos to give you the correct line. Right, and in this case, if you look over here, this was my line. I left mine in, and I'll show this to you on the graph next. Here's what I typed in, and it actually gives you the slope and the y-intercept. These other points we'll be talking about later, all right, but basically this is what's called the correlation coefficient. We'll talk about that at some point, and this actually plots what's called a residual plot. Again, we'll talk about that later. For now, just focus on, it gives you the slope and the y-intercept for the actual best line of fit. All right, so you can see here, the line of best fit is actually the blue line. My line is the red line. So you can see how far off my line was. But again, that makes sense because I looked at these 2 points as outliers. So my point's actually a little bit lower. Okay. All right, so let's go back to the original problem. Okay, so remember what we were supposed to do is figure out, well, what's our prediction for the number of points Antonio makes. In my line, I did the math here, so you can take a look at that. In my prediction, Antonio earns 758.4 points. But when we use the best line of fit, the least squares regression line, you could see it's a lot more points. So this would be the more accurate one based on the points we were given. All right, so let's see how far off that was total. Yeah, okay, so the difference between the two is 283.5 points. I was 283.5 points under because my line was so much lower. So that makes sense if you think about it, but probably not accurate. All right, so here's one last thing I want to say. The other thing that happens when I'm looking at this is I'm looking at this and thinking it may not be a straight line. This might actually be a curve. So it possibly could be an exponential function or a quadratic function. Guess what? Desmos will let us do that too, and we'll be talking a little bit about that more. But in the video you're going to watch tomorrow, you'll see that teacher actually put in a curved line of fit too. I think, again, that would have been more accurate in this situation. All right, that's the end of the video. Don't forget to get those questions answered and get them into me on Google Classroom. All right, thanks for watching.